Hi, we are back again looking at differentiation. Today we're going to have a look at 8H. Again, moving through the Cambridge textbook for Year 11 Advanced. And we're going to differentiate using the quotient rule. When I asked you guys in class the other day what quotient meant, or if you'd heard of quotient before, you actually hadn't. So what quotient means, quotient is the result that you get when you divide something by something else. So that's why the functions that we're going to have a look today at, y would be a result of a top function we're going to call u and another part that we're going to call v. So we're going to have a division in there, hence quotient. So we're going to be finding the first derivative, dy dx, of a function that looks like something divided by something else, like this one down here we're going to have a look at to start with. 2x plus 1 over 2x minus 1. So basically a function made up of two functions where they're divided. The rule that we're going to use is here. I'm going to do that in blue. This is again given to you in your HSC formula sheet. You do not need to memorize it, thankfully. I did when I was at school, so I'm so glad for you guys that you do not need to. And the rule is, if we have a function of this form, our dy dx is equal to v du dx minus u dv dx all over v squared. Let's have a look at a question and just get straight into it. Our first example says to differentiate each function, stating any values of x where the derivative is 0. So I'm going to redo it over here and have a look at it. So there's our function rewritten. We are u over v, okay? So I'm going to let my u equal to 2x plus 1 and my v be equal to 2x minus 1. Hopefully you've watched and worked through the product rule. If you haven't, go back before you watch this video and look at the video before the product rule. You need to do that before you do the quotient rule. So now that I know that you have done the product rule, we can move straight forward. So I've got a u, so I can now find a du dx. I can differentiate u with respect to x and I will get 2. Likewise, I can differentiate my v with respect to x, and I get a dv dx that is equal to 2. Let's write down that rule. Better still, let's look at the rule again, because you guys will be copying it off your formula sheet. It's v du dx minus u dv dx all over v squared. You cannot switch the v and the u around. The u is our top part. It comes second after the minus. The v is our first one, and the v is on the bottom squared. So you need to have it in that order. The u has to be on the top, the v has to be on the bottom. So v du dx minus u dv dx all over v squared. Let's write that down. Dy dx is equal to v du dx minus u dv dx all over v squared. Now a lot of you have a temptation to forget that v squared on the bottom, and you're just ending up with this top part. You need to be really careful to get it right. It needs to have that whole allotment in there. Okay, so our dy dx is going to be equal to, actually I won't do it to the right there, I'll do it underneath. It's much nicer. So dy dx equals, no, I haven't got y equals and I've flown on. I am now finding dy dx. So don't write y equals and follow that down. I know a lot of you are doing that as you're learning. No, we are now up to dy dx. So let's distinctly make that note that this is now dy dx. Let's substitute in. Our v is 2x minus 1. Our du dx over here is equal to 2. So I'm timesing that by 2. I'm taking away my u, which is 2x plus 1, and I'm multiplying that by dv dx, which is also 2. And it is also over v squared. So I'm going to be squaring the 2x minus 1. Okay, let's neaten up that top row because the bottom row looks great. We've got a 2, lots of 2x minus 1, minus 2, lots of 2x plus 1, and it is all over 2x minus 1 squared. Some of you in class the other day asked, do I need to expand the bottom line? No, expanding that at this point will not help us in any way. Let's work on that top line, and if we get some term on the top line that is one that we can cancel with on the bottom, we will deal with that then. Now, have a look at the top. I cannot really pull anything out there yet. Well, I guess I could pull a 2 out. I don't think I'm going to. What I'm going to do is I'm going to expand both of those and then collect like terms. I think that's the best bet. If you want to collect the 2's out the front, and then that would work as well. I'm going to go this way. I'm going to have 4x minus 2 minus 4x minus 2. So be really careful that that minus is carried through with that minus 2 as you move along. And it is all over 2x minus 1 squared, which beautifully happens to be minus 4 all over 2x minus 1 squared. So we haven't expanded, our bottom line. Likely we didn't. It would have wasted our time. It wouldn't have helped us in any way. That is our solution. But have we answered the question? Let's go back and have a look. The question said differentiate each function. Well, we've done that. Stating any values of x where the derivative is equal to 0. Let's have a look. Our derivative is equal to 0. Let's have a look at it. Let's pop our derivative to 0. Now, let's look for x values where our derivative is equal to 0. What can we do? Well, let's multiply our bottom line out. And what you're going to probably notice is we're not going to have anything. So if I multiply both sides by that, these cancel out here. I've got a minus 4 is equal to 0. No solution, no values. No solution here. No values of x where dy dx is equal to 0. We can't do anything with it. And that's okay to write that. And that's something I know you guys are needing to get a hang of, is that sometimes we're going to have a no solution, and then that's okay. Rightio, that was our first question. Let's do the second one. We are going to differentiate this one now. Y is equal to x over x squared plus 1. Okay, so again, you need to recognize the function. Okay, it is a quotient. There is a u on the top. We're going to have a v on the bottom. So u is equal to x. V is equal to x plus 1. And the more you do of these, the more you'll feel comfortable doing that. Okay, now we can differentiate our u with respect to x to get 1. And we can differentiate our v with respect to x, which is 2x. When I'm saying it's with respect to x, it just means I have x on one side of the function and my other values on the other. We can pop that into our formula. So you need to go to your formula sheet and you need to copy it down. I would be putting my formula sheet right next to my page and copying it down off my page so that I get it written correctly. V du dx minus u dv dx, but it's all over v squared. Don't forget that part. And then we're substituting it in. A lot of people end up copying this rule down wrong, and there's no excuses for that because you are given that. Okay, dy dx is equal to v x squared plus 1. If you want to pause it, you do it yourself and then see if you get the same as me. That would be great. Times by du dx, which is 1. I'm not going to put the 1 in there. I don't need it. I'm just going to leave it like that. Minus my u, which is x, times my dv dx, which is 2x. It is all over v squared. Okay, let's continue on and let's make it a little bit neater. We have got now x squared plus 1 minus 2x squared all over x squared plus 1 all squared. I'll put a little equal sign next to it. Okay, I don't really need these brackets here now. They're not doing anything. So we can remove those. I might just rub them out here like this. Oops. Look at that one. Okay, x squared plus 1 minus 2x. I'm going to put the 1 down. What's x squared minus 2x? It's minus x squared all over x squared plus 1 all squared. Now, you can leave it like that. There's not a lot else we can do with that. The bottom line is not a difference of 2 squares. We can't do anything with that. It's a positive in the middle, so it's a positive of 2 squares, which we don't have a rule with. The top is a difference of 2 squares. You could expand that if you like. So let's do that. 1 minus x, 1 plus x. It doesn't really help us yet, but we have that option there if we like. What was the question asking us again? Let's scroll back over, and it said stating the values of x where the derivative is equal to 0. We'll scroll back over. So we want to find where dy dx is equal to 0. So we want to find where this function here is equal to 0. So 1 minus x, 1 plus x, all over x squared plus 1 is equal to 0. What do you think? Have you had a little think? So we need to get rid of this stuff on the bottom line. We need to get rid of the x squared plus 1. If I multiply both sides by x squared plus 1, they will cancel out on this side, on the left, and on the right, I will end up with a 0. So you guys do that. So what your next step will look like is you will end up with a 1 minus x, 1 plus x equals 0. We then set each bracket to 0, like we should be very comfortable with doing now. Okay, that is the roots of a quadratic equation. And I'll end up with x is equal to 1, or 1 is equal to x. And I'll end up with x is equal to minus 1. And they're our solutions for where our derivative is equal to 0.